Okay, so for number 1 here, we've got an element reacting with an ionic compound producing a new ionic compound with a different element. What kind of reaction is that? Single replacement, 1 mark. Okay, we've got to write it out in words. So we've got sodium plus magnesium chloride gives us sodium chloride plus magnesium. 1 mark. No capitals. Okay, and then we have to balance it. Right now, the largest number is 2, and it's attached to chlorine. So there are 2 chlorines on the reactant side, but there is only 1 over here. That means a 2 has to go there. That gives me 2 sodiums, so a 2 has to go there. There's 1 magnesium on both sides, so now it is balanced. Okay? If they don't have the 1s, that's fine, but make sure they have the 2s in the right place. That is 1 more mark. So 3 marks for number 1. For number 2, 2 elements react to form a compound. What kind of reaction is that? Synthesis. All right. So 1 mark for synthesis. Written out in words. Calcium plus phosphorus gives us calcium phosphide. 1 mark if it's written that way. Now we need to balance. Says always balance the thing present in the largest number first, but it's already balanced. Okay? So, if we go back, we look at calcium here. We need a 3 there, and now this equation is balanced. Now, is there a problem with the way that Ca3P4 is written? Did anyone notice the mistake on the quiz? Okay, nobody said anything, right? But it should be Ca3P. Look at this. Ca is 2 plus. Phosphorus is 3 minus. What should that compound read? Ca3P2. Okay, nobody knows the mistake. We are omitting number 2 because it had a mistake in it. Okay? I'm surprised nobody's. I kept looking at it going, something doesn't look right about that. Something doesn't look right about that. Nobody said anything. Okay? What's that? Or too shy? Don't be shy. If you think I made a mistake, come up and say, Mr. Clear, I think I made a mistake. Most of the time I'll tell you to sit down, shut up. But, okay? Sometimes you might be right. This would have been one of those cases. All right. Number 3. We've got lithium hydroxide. Okay? So written out in words here. Lithium hydroxide. Okay, is reacting with calcium phosphate. Okay, to give us lithium phosphate. I'm going to run out of room. Plus calcium hydroxide. Okay, 2 ionic compounds react to form 2 new ionic compounds. Reaction is double replacement. Alright, so 2 marks so far, 1 for written as words, 1 for double replacement. Now we have to balance it. Okay, this compound is correctly swapped and dropped. There are 3 calciums on this side, but there are only 2 over here. So I'm going to start by putting a 3 there and balancing my calciums. How many hydroxides does that give me now? 6. Okay, so if I go back over here, what needs to go in front of lithium hydroxide? 6. How many lithium does that give me? 6. So I need a 2 over here. 2 times 3 is 6. That happens to give me 2 phosphates. And there are 2 over here. So properly balanced, that's 6, 1, 2, 3. Okay, so 1 mark for that one. All right. For number 4. Right, we've got to write it out in formula form. Hydrogen sulfide. Hydrogen is +1, sulfur is -2, so we're looking at H2S. Okay, reacts with strontium, Sr. Right, to produce hydrogen gas, H2. Right, hydrogen is one of the special ones, comes as a pair. Plus strontium sulfide, Srs. Okay, because this is a +2 and that is a -2, so that one is correctly swapped and dropped. So if they have that, give them a mark. What kind of reaction is that? Single replacement. Okay, so 1 mark for single replacement. Now we got a balance. Good. If they left it exactly as it is, okay, it is correctly balanced. The pair that aren't pairs? Right, that's why by itself it is a 2 over here. Right? It isn't always a 2 in a compound, not always. Okay? But when it's by itself, it is always a 2. It just so happens on this one that because this is -2 and this is +1, hydrogen ends up being a 2 in that compound. Okay? Hydrogen, when it's with nitrogen, is H3N. Okay? It all depends what it's with. When it's by itself, it has to have the 2. If it doesn't, it's wrong. Okay? And then probably your balancing is wrong too. All right? Everybody with me there? Okay, we got to remember which ones are our special elements. Okay, number 5. This stuff is octane. It's the stuff that your car likes. Okay, the active ingredient in gasoline. Okay, C8H18 burns in the presence of oxygen to produce carbon dioxide and water. If they have that, give them a mark. What kind of reaction is that? Combustion reaction. So if they have combustion, give them a mark. Now, 2 special rules for balancing combustion reactions. The first rule is balance alphabetically. What is the second rule, Alex? Number of carbons. Right, the rule of 2. You have an even number of carbons, you start balancing with a 2. Okay, 2 special rules for balancing combustion reactions. 2 times 8 is 16. So I need a 16 here, balancing alphabetically. Okay, 2 times 18 is 36. So 18 times 2 is 36. All right, now I've got to look at my oxygen. 16 times 2 is 32. Plus 18 more is 50. 25 times 2 is 50. So now the reaction is balanced. If they have 2, 25, 16, 18 for their balancing numbers, they can have a mark. Okay, and last one, potassium sulfide, K2S. Okay, breaks down into potassium, K, and sulfur. Highlighted on your periodic table as an octuplet. Comes as a set of 8 whenever it is by itself. Give them a mark if they have that written down. What do we call a reaction type that involves breaking down? Decomposition. Okay, 1 mark for decomp. And now we got a balance. Always start with the thing present in the largest number. 8 sulfur, 16 potassiums. We're done. Alright, so if they have 8, 16, and 1, okay, or 8, 16 blank, they're good there, 3 marks. So the whole thing is actually out of 15 because we are not counting number 2. Alex? It's wrong. Yep. Alright, so give them a mark out of 15. Let them see it. Put it in the marking box, please. We're going to go through a few more examples of how to predict the products of a reaction and balance the reaction afterwards. Okay, because we haven't done reactions for a while. We've had a few days where we were working on the research project, so now we need to get back at it. We're going to work on predicting and reactions today and on Wednesday. On Thursday, we'll be in the lab. Okay, and we'll have a quiz on this again on predicting this time. Okay, Friday, we'll see. Right? We may be spending Friday working on reactions again. We may not. If we are not, we'll be starting the last thing in this unit. And before the end of class today, I will tell you when your unit exam is going to be. So you will have between 10 and 14 days notice, okay, of when your unit exam is so you can do adequate preparation. All right. Things we got to remember about predicting. The first step toward predicting the products correctly is being able to tell what kind of reaction is going on. Right? Once we know what kind of reaction is going on, it becomes pretty easy to find the right pattern, okay, and get our products together in the right order. So, for number 1, I've got an element reacting with a compound. What's our only reaction type that does that? Single replacement. So in a single replacement, okay, the metal or the element that's by itself needs to replace something in the compound. Now, it needs to replace in the compound the thing that is like it. And by that I mean, if this is a metal, which it is, it needs to replace the metal in this compound. Now, in this compound, hydrogen hydroxide, more commonly known as water, okay, what is acting as the metal? Hydrogen or hydroxide? Hydrogen. Hydrogen is positively charged. Metals are positively charged. So, hydrogen is behaving as the metal because it is listed first. All right? So, on this side then, hydrogen will be by itself, and potassium will be with hydroxide. So that's the first 2 steps. The first 2 steps of predicting are identify the reaction type and predict the products. The next thing is that we have to look for swap and drops and special elements. Okay, is there an ionic compound here? Yes, KOH is an ionic compound, metal and a polyatomic ion. So I need to swap and drop it. +1, -1. Okay, that compound is okay the way it is. Do I have any special elements? Yes, hydrogen is one of our molecular elements. It comes as a pair always when it is by itself, so it needs a little too. All right, now that I've done that step, now I can do what? Now I can balance. The reaction is done. Okay, now I can make sure I've got the same amount of everything on both sides. Biggest number in the reaction is 2, so I got to go back over here and put a 2 there. Okay, that gives me my 2 hydrogens, but it also gives me 2 hydroxides. How many hydroxides are there here? Just 1. So what needs to go in front of potassium hydroxide? 2. But that gives me 2 potassiums, so I got to go back over here and put a 2 there. Okay, the only thing that's a 1 is hydrogen. Okay, is that ringing a bell? Okay. Okay, for number 2, I've got an ionic compound, in this case copper 1 sulfide, reacting with sodium hydroxide, also a compound. What kind of reaction starts with 2 compounds? Double replacement. Okay, we have to remember that in a double replacement, what we typically do is swap the metals. Okay, so each metal will have a new partner on the other side. So copper 1 ends up with hydroxide. Okay, sodium ends up with sulfur. All right. How did I know on this side that the charge on copper was only 1 and not 2? Right, because essentially sulfur is always a -2, and if I drop down a 2 here and I didn't have a number here, that means that copper had to be a +1 in this compound. All right, so that means it is still a +1 on this side. Okay, getting in a reaction doesn't change it from one kind of copper to another. All right, so we've got CuOH -1 +1. Is that compound swapped and dropped correctly then? Yes, it is. All right, this compound, sodium is +1, sulfur is -2. Is that one swapped and dropped correctly? No, I need this to read as Na2S. All right, now I've swapped and dropped everything. There are no special elements because there are no elements by themselves. Okay, so I don't have to worry about that part. Now I need to balance. I have 2 sodium over there. Now I have 2 over here. Okay, but that gives me 2 hydroxides. So what needs to go here? 2. Okay, does that give me 2 copper? Yeah, and there's 2 copper over here, so that works out pretty well. Now everything else is balanced. Okay, so the steps are as it shows there on your flow chart. The first step is identify the reaction type. Second step, okay, predict the products. Okay, third step becomes kind of, it's different for different reaction types, but in general, Okay, the third step is look for special elements and swap and drop. Okay, unless it's a combustion reaction that has all its own special rules. Okay, and then balance after that. Okay, all right. I want you guys to try 3 and 4. I'll give you a few minutes to try 3 and 4. Okay, on your own here, and then we'll do them together. All right, let's have a look at 3 and 4 here. Okay, so for number 3, I've got element reacting with element. Okay, what kind of reaction is that? Synthesis. Okay, so in a synthesis reaction, they simply go together. So Fe goes with O. Now, Fe is a multivalent metal. How do I know what charge it is? Because they don't tell me, and they don't give me any way to figure it out on the reactant side. Something we haven't covered yet. Okay, anybody know what it happens to be? Okay, if this situation arises, and it does on rare occasions, you go with the first charge listed on your periodic table. That is the most common charge for each multivalent metal. So for iron, what's the most common charge? 3. Okay, 3 is listed first. All right, so iron's most common charge is 3+. Oxygen's always -2. We drop and swap. Fe2O3. All right. So now we got a balance. I got 3 oxygens on this side, and I've got 2 over here. What's the lowest common multiple? 6. So if I put a 2 here and a 3 here, my oxygens work. 2 times 2 is how many? 4. So I need a 4 over here with my irons, and now it's balanced. All right, everybody good with that one? Okay. Now, I have, on occasion, put a question like this on a quiz, but I've done this instead. Okay, instead of writing it Fe plus O2, I wrote it as O2 plus Fe. Okay, why would I do something like that? Yes, absolutely. To confuse you. No, not really. Actually, it's to see whether you remember that when you write an ionic compound's formula, you write what first? The metal. Okay, by changing that around, I would get half of you. Not because you don't know you're supposed to write the metal first, but just because you would forget. Okay? It's one of those things we have to ingrain in our minds. Whenever we write an ionic compound, the metal's always written first, and then, okay, the non-metal. But if I write it in reverse order like that, it ends up being a totally different thing. Even though if I wrote it this way, pretty much everyone would get it right. All right? So little things like that, watch for. I might just do that on the next quiz or something. Okay? All right, number 4, I've got a compound. That's it. What's the only reaction type that starts with just a compound? Decomposition. It's the only thing that can happen, right? So it's going to break down into its elements. Now, with decomposition reactions, you really have to watch for your special elements. Okay? They almost always involve at least one special element. N, when it's by itself, is always a 2. Phosphorus, when it's by itself, is always a 4. All right, so now we got to balance everything. I've got 4 phosphorus over here, okay, and I've got 1 over here. So what should I put in front of N3P? A 4. Okay, how many nitrogen does that give me? 12. So a 6 there will give me 12. All right, always start with the largest number first and balance from there. Okay, give 5 and 6 a try. Give you a couple minutes here, and then we'll go over those. All right, let's have a look at 5 and 6 here. So in question number 5, we've got 2 ionic compounds reacting with each other. Reaction is double replacement. Okay, so in a double replacement, we swap the metals. All right, that means calcium's new partner is nitrogen, magnesium's new partner is fluorine. Okay, what do I always have to do with ionic compounds? Right, find the charges, swap and drop. All right, so nitrogen is always a -2, calcium is always a, nitrogen is a -3, right? Sorry, manganese, sorry, not magnesium, sorry, manganese, you're right. Manganese. All right, so nitrogen's -3, so Ca3N2 is our formula for calcium nitride, and then manganese with fluorine, okay? Manganese is a multivalent metal. So I have to go back to this and figure out what the charge was on manganese. If nitrogen's always -3 and there's 4 of them, that's 12 negatives. Okay? So I need 12 positives. What times 3 will give me 12? 4. So this is manganese 4. Okay, manganese plus 4. All right, so that means MnF4. Now we got to look at our balancing here. I could probably balance nitrogen or fluorine first. It probably doesn't matter either way. Okay, I'm going to start with nitrogen. Okay, and see what happens here. Okay, nitrogen's a 4 here, but it's only a 2 over here. So what do I need to put in front of this? Okay, a 2. All right, that gives me 6 calcium. So if I go back over here and put a 6 there, okay, that's balanced. Now how many fluorines do I have? 12, right? 6 times 2 is 12. What times 4 will give me 12? 3. Okay, does that make my manganese work out? It does. Okay, so now we're set up. Now we're good. Okay, probably one of your trickier balancing ones. But again, as long as you follow the rules, okay, balance the biggest one first, you're almost always going to work out okay. All right, for number 6, ionic compound reacting with a single element. Reaction type is single replacement. All right. In a single replacement, okay, the element by itself needs to replace the thing in the ionic compound that is like it. Phosphorus is a non-metal. Which one of these two things, lithium or bromine, is the non-metal? Bromine. All right. So that means bromine's going to be out by itself. Lithium will be with phosphorus. Okay, and we'll have this set up. Now we've paired everything up. Now the next step is swap and drop ionic compounds and look for special elements. All right. This is a -3. This is a +1. So we've got Li3P for the formula, okay, for lithium phosphide. And is bromine special? Yes. Okay. So now we can go back over here. Phosphorus is present in the highest number. There's 4 over here. So I need 4 over here. That gives me 12 lithium. So I need a 12 there. Okay, and that gives me 12 bromine as well, so I need a 6 here. And now it's balanced. Sometimes we just get big numbers. All right, I want you guys to try the last 4 on here. All right, let's have a look at these last 4 here. Okay, so on number 7, I've got carbon and hydrogen together in a compound reacting with oxygen. The only reaction type that does that is combustion. Okay, so this is a combustion reaction, and the products of a combustion reaction we don't have to think about, we just memorize. Carbon dioxide and water, always. Okay, there's no having to rearrange or think about that. That is always what the products of a combustion reaction are. All right. Special rules for balancing combustion reactions. Balance alphabetically and the rule of 2. Does the rule of 2 apply on this one? No. It's an odd number of carbons. I do not need the rule of 2 here. All right. So C9, C9. All right. H20, 10 times 2 is 20. Now I can balance my oxygens. 9 times 2 is 18 plus 10 more, okay, is 28. So 28 over 2 is 14. Okay. Does that one make sense to everybody? All right. Number 8. Element plus element is a synthesis reaction. So CS and S go together. Cesium is a +1. Sulfur is a -2. So we've got CS2S, right, as our final setup here. Now we got to balance S8. Okay, S1, so I need an 8 here, okay, and that gives me 16 cesiums. All right, for number 9, I've got zinc oxide with rubidium chloride, all right, and these are both what kind of compounds? They're ionic, so this is a double replacement reaction. So I'm going to swap the metals partners. Zinc ends up with chlorine. Rubidium ends up with oxygen. Okay, and with all ionic compounds, I now need to swap and drop. Zinc is a +2, chlorine is a -1, so I've got ZnCl2, and then I've got rubidium, which is a +1 with oxygen that is a -2, so I've got Rb2O. Okay, so we'll start with chlorine. There's 1 over there. Now there's 2 over there. Now there's 2 over here. There's 2 rubidiums and 2 rubidiums, so that means that everything else in this is a 1. All right, last one. Did you have this one on your quiz today? Yes, you did. Okay, this was one of the questions on your quiz. So it's a combustion reaction. Those always produce carbon dioxide and water. I balance alphabetically. Do I need the rule of 2 this time? Yes, I have an even number of carbons. So start with a 2, that's 16 carbons. 16 carbons. 2 times 18 is 36. 18 times 2 is 36. 16 times 2 is 32, and 18 more is 50. 25 times 2 is 50. All right. Now, you have in your possession the reaction worksheets we started last week. Okay? I would imagine most of us are not nearly complete. And many of those have prediction problems on them. So, let's pull those out. Okay, and get going on those, and I'd be happy to go over any questions that you have from those worksheets. Yes. Okay, so you should have one worksheet that looks like this one, where you got some balancing at the top, and we said 6 and 7 were just challenge problems, and then the rest of it was predicting problems, including the back side of that page. Okay, you should also have one that looks like this, Science 10 More Reaction Practice, okay, that's got some reaction stuff on it that's already predicted for you, okay, and then a few on the back side of that, a few further on that are prediction problems. Okay, and then you've also got this prediction worksheet, I believe, okay, in your possession as well. All right, so you've got quite a few there, okay, to work on. All right, any one of those you got questions on, and we'll go over them. Are there any questions right now? Oh, it just means it's nitrogen by itself. So anytime you see the word nitrogen gas, it means N2, nitrogen by itself as an element. Okay. Okay, we're going to have a quick look at number 10 here, guys. So we've got copper 1 sulfide. That's Cu with S, but this is -2, and they're telling us copper's +1, so it's Cu2S. Okay, reacts with oxygen gas, okay, to produce copper 1 oxide, so that's going to be Cu2O, okay, and sulfur. Now, is sulfur special? Yes, okay. All right, so it makes S8. So this one actually you didn't have to predict this one. The reason for that, it's really tough to predict what this one does. Okay, so it's not kind of a typical replacement reaction. So on this one now, we got to balance everything. There's 2 copper, 1 sulfur, 8 sulfur. So let's do the sulfur first. Okay, I need an 8 here. That gives me how many copper? 16. So I got to go over here and make 16. That gives me 8 oxygens, so I need a 4 here, and now it's balanced. Yeah? Oh, sorry, sulfur dioxide. Yep, sorry, I screwed that all up. Sorry, guys. I didn't keep reading to the second line. All right, Cu2S plus O2 gives Cu2O plus SO2. All right, so now a little bit trickier here for balancing sake. Okay, the copper's already balanced. Okay, the sulfur's already balanced, but oxygen is not. There's 3 oxygens on this side, but there's only 2 over here. What's the lowest common multiple of 2 and 3? 6. All right. So if I'm going to do that, okay, I'm going to have to make 4 more here. Agreed? Okay, so I can make 4 more here, okay, by doing this, okay, and we'll see what happens with that. By putting 4 there, I've given myself 8 of these. So it might screw something up here in a minute, but we'll see. Okay, 8 sulfur. So I need 8 sulfur here. 4 times 1 is 4 plus 16 is 20. Okay, what times 2 gives me 20? 10. All right, now, what do we notice about all those balancing numbers? They're all even. What can I do with them? Right, I can reduce. Okay, and we always do. Anytime you have balancing a balanced reaction where all of the numbers can be reduced, you do so. All right, all of these can be divided by 2, all right, to get us down lower. All right, so we'll have 4 CUS, we'll have 5 O2, we'll have 2, and we'll have 4, and now it'll work. Okay, that's a tricky one, right? Pretty tricky one. The reducing part? Yes, and you have to. Anytime that all your balancing numbers can be reduced, you reduce them. Okay? You don't change any of the little numbers, okay? But anytime the coefficients can all be reduced, you reduce them. Devin.